I'm recording. Okay, today we're going to be talking about a topic in probability that's very useful in not only gambling, okay, but business and everyday life. If you've ever participated in a raffle, you've dealt with this concept, and it's called expected value. In other words, if you play a game or perform an experiment enough times and there's a cost to playing, what is the overall outcome on average? Okay, if you play it enough times, that's what expected value is. Okay, we're going to start by introducing the concept. I'll show you how to figure it out, and then we'll do a couple of real life examples to show you what that means. Okay. Before we get started, I want to share my screen with you, my browser, and just point out again where this material is in our course. Okay, so we're in week 9 currently. Okay, we did Bayes' theorem the last time we met. Okay, and now here we're doing expected value. Okay, I am using these expected value notes, this PDF file, okay, in order to walk through some examples. Please note, I did put a link to a Bayes rule calculator in here. Personally, I think it's probably easier, as long as you understand the probability trees we went through last time. It's easier to compute it yourself than to try to figure out the calculator, but here it is in case you want to give it a try. And again, just to mention, we've got 2 sets of homework this week. Again, only 10 questions apiece. But most important is this survey. Please fill out the survey. I know it's only 5 points, but it provides me with valuable feedback about how you think the course is going, how it's working for you, any suggestions you have to make it better. Okay. Ideally, I know we all want to meet face to face. I can't fix that part of it right now, but that said, there's a lot of things in here I can fix as long as you give me suggestions. Okay. So that said, I'm going to bring up the chat. Again, you're more than welcome to ask questions out loud. Just unmute yourself and ask. But if you prefer, you can always type your answers or your questions in the chat. So let me bring up my notes and share those with you. Okay, so let me just share that. Okay, so everybody should see expected value. Is it worth it? Okay, everybody seeing that? Okay. So suppose it's pre-COVID and you're on a family outing and you happen to pass a traveling carnival. You come across a game of chance. It costs $10 to play. If you roll a die and it lands on a 4 or a 6, you win $25, minus the cost of playing, of course. But assuming the die is a fair one, how about the game? Is the game a fair game? What do you think? Okay, in your understanding, okay, by your understanding currently, is this game fair? Okay. Now, again, you can unmute yourself and speak out. You can type what you think it means to be a fair game and whether this game meets your criteria.
No, it's not fair.
You don't think it's fair? Okay. Chris, why do you think it's not fair?
Because it says, it says assuming the die has not been rigged. I read that wrong.
Okay. Yeah, we're assuming a fair die. Okay. So they're not cheating you that way. Is there anything about the way it's worded that kind of makes your hair on the back of your neck stand up?
Carnival?
Yeah, carnival. We never expect those to be fair, do we? But again, let's take a look at it, and everybody else, feel free to chime in, okay? How about the probability of rolling a 4 and a 6? What's that probability? Those are 2 numbers on a 6-sided die, right? So the probability of rolling a 4 or a 6 is 1/3. Okay. What's the probability of not rolling a 4 or a 6?
2/3.
2/3. Okay. And if you roll a 1, a 2, a 3, or a 5, you're out $10, right? So that's kind of what bothers me about this game. Okay. But let me give you the statistical definition of a game being fair. Game is fair if its expected value is 0. Okay. Now, expected value, I realize I haven't defined it yet, but you can think of that as once you factor in the cost of playing the game, you're equally likely to win or lose. Okay. You net out, you net 0. Okay. So that's kind of a motivation. Okay. So let's remember the kind of parameters of the game. We're going to play with it a little. Okay. In order to win, you have to roll a 4 or a 6. And there's a 1/3 chance of doing that. If you win $25, but it costs you $10 to play the game. Okay. So if you win, you really only net $15, right? Because it costs you $10 to buy a ticket. Everybody understand the net 15?
Yep.
Okay. Everybody understand that? Okay, good. All right. Well, let's talk a little bit about expected value then. All right, so here's the mathy definition. The expected value of an experiment is the average value of that experiment when you repeat it a large number of times. Okay, another way, average value, mean value, if you play it a lot. Okay, when the experiment is a game or an investment, the expected value represents your average winnings or the average value of your investment. Now, again, kind of makes sense in a game, okay, to see, all right, is this fair? But realize that other entities use expected value to set prices of things. For example, have you ever bought electronics, say at Best Buy, and you're checking out, and the cashier says, hey, for only $39.99, you can add a 2-year, consumer protection warranty to your product. You want to add it? Okay, basically, there's an expected value associated with that additional charge. You're making a $39.95 investment in your product, but is it worth it? Okay. Another use for expected value is with insurance companies. This is how they decide what to charge you in the way of a premium. They basically have statistics on what their payout value is on a particular type of policy, let's say auto insurance. Okay. And then they use that information to determine what the expected payout would be. Okay. And so essentially, this is something that's not just used in, carny games or casino games or stuff like that, although we'll do some examples like that. It's also used in business. Okay. And it's important. Okay. Because if you don't get the expected value right, you stand to lose a lot of money. Okay. So let's talk about how you calculate expected value. It's calculated as a weighted average. Okay. So essentially, you're going to take each outcome of your experiment or your investment, and you're going to weight it by its probability. Okay. So that's what I mean by a weighted average. Okay. So let's say we want to calculate the expected value of an event X. This is usually the way you write it, E of X. Okay. Here's what you've got. You've got the outcome, okay, of event 1, right? Outcome 1 weighted by its probability plus outcome 2 weighted by its probability all the way out to however many outcomes you have weighted by their probability. Okay. This little thing that looks like a V is actually a Greek letter nu. Don't worry about it. It represents the value of that outcome. Okay. And P sub I represents the probability of that outcome. So just think of it as outcome value times its probability. Okay. So I'll write that over here. Outcome value times its probability. Okay, so let's figure out our carnival game expected value. So first of all, we have to think of what are the possible outcomes of this game? Okay, so what do you think? What are the possible outcomes of that carnival game? What do you think? Either shout them out, type them in the chat.
Sides of the die.
Okay.
Yes, or like you win or not win.
Win or not win. Okay,
Yeah.
I like that. Win, lose. That's nice and easy. Okay, so what's the value of each outcome to you? Well, let's think about that. Win. Okay, remember how much the win was? 25 bucks. But it cost you $10 to play the game. That's what I meant about a net. Okay, so you net $15. Everybody all right with the value of a win? Now, if I lose, they don't give me anything. So that means I'm just out 10 bucks. Notice the negative sign in front of the 10. All right, so here are my values. Positive 15 if I win, negative 10 if I lose. All right, we kind of even talked about the probability. The probability of winning with a 4 or a 6. Okay, those are 2 out of 6 possibilities on a fair die, or 1/3. Lose with anything else. Okay, since I've only got 2 outcomes, win or lose, I can do this. Okay, so here are our 2 probabilities, 1/3 and 2/3. Anybody got questions about the values or the probabilities? Questions on the values or the probabilities? No? Okay. I want to, again, make sure everybody understands why I netted out the values like this, because it costs money to play the game. All right, well, we are in a position to actually figure out the expected value of playing this game. Okay, so I'll write it like this. Expected value of X. And let's first put win over here and then lose over here. Okay, so the value of winning was $15, and I had a 1/3 probability of doing that. And the probability of losing was negative $10, right? If I lose, I'm out 10 bucks. Probability of that is 2. Okay, so everybody understand, here's that U1, P1 plus U2, P2. That's what these things are. Okay, everybody understand how I'm plugging things into the formula? Okay, the rest of it's a calculator problem. Okay, just type this into your calculator, this right-hand side. When I did that, I got the expected value of X equals negative 1.67. Okay, it actually came out as fraction, but it's a monetary amount, right? Because all of these outcomes are in dollars, right? And the probabilities don't have any units on them. So my outcome is in dollars. Okay. What does this expected value mean in the context of the problem? Well, if you play the game enough, on average, you will lose $1.67 on each play. Now, this can be confusing to people because they say, well, wait, I'm either going to win 15 or I'm going to lose 10. Yes, but if you play the game a lot of times, let's say you play it 15 times or whatever, okay, it all averages out. And on average, you will have lost $1.67, lose, because your expected value is negative. Okay. Everybody understand the calculation. Okay, everybody good with this? Okay. So based on this expected value, what do you think now? Okay, Chris said before he didn't think the game was fair, but he was wondering about the die. Okay, what do you think now? Is it fair?
I think it's fair. It's just set up for you to lose.
Okay, well, statistically speaking, this is not a fair game because the expected value isn't zero. Okay, so statistically speaking, game is not fair. Okay, and the reason is the expected value of the outcome is not zero. Okay, now every financial transaction has at least two sides to it, right? If you were the one running the carnival game instead of the one playing, what do you think? Would it be a fair game? Why or why not?
It still wouldn't be fair because it's not zero, but it would be in your favor if you're running it as opposed to playing.
That's very, very true, Alicia. Now let's ask a question. What does this mean for the person running the carnival game? What does an expected value of negative 1.67 mean?
That they're going to be making money when people play.
Right. If you sit there at your carnival booth for, say, 6 hours a day and 100 people play your game, okay, on average, you're going to make $1.67 per person. Okay. And that's why they run the game, is because they're making money on it. Okay. By definition, it's not fair. Okay. But the person running the game makes $1.67 on average. Okay. Okay, so it's in their interests financially for it not to be a fair game. All right. If it were a fair game, they'd be sitting out there for 6 hours for no good reason, right? Because everybody would net out. They, on average, maybe some days they'd make a few bucks, some days they'd lose a few bucks. Okay, but on average, the expected value would be zero. So again, the expected value for the player needs to be negative. Otherwise, there's no point in running the game. Same thing is true of a raffle. Okay, same thing is true of those consumer protection policies. Okay, now I'm not saying people are trying to swindle you. This is just business, like somebody said before. Well, it's not fair, but I mean, that's the way the game works. Yeah, so my point is understand expected value so you have an edge in figuring out just how unfair is the game. Okay, a negative 167 isn't that bad. Okay, so I just want to make sure everybody understands the point here. Okay, so what would make the game fair? Okay, so something you could do, make the game fair. Anybody have any suggestions?
You can add another number to the win category.
Right, change the probability of winning. Or my suggestion would be lower the cost to play. Okay, so either one of those might bring the expected value to be zero. All right, everybody kind of understand how, again, this is something if you're going to run a raffle or you're going to run a game or you're going to set premiums or an investment like this, you've got to figure all this out in advance. Okay? Because essentially you're not doing it for free, right? You're expecting to make something. Lots of churches, even community colleges hold raffles. I know used to work at Estrella Mountain, and about 10 years ago, I don't know if they still do it, they used to have a car raffle to raise scholarship money. Okay, and they'd sell like 1,500 tickets. It cost $50 to buy a ticket, but you could win a new car. The cars were donated. And so basically there was a tremendous interest in playing this raffle, but it had a negative expected value. Of course it did. The point was to raise money for scholarships. Okay. And we can talk about that later if we've got time. Okay. All right. So that makes sense. So again, just to reiterate, a game of chance is fair if the expected value is 0. And again, change the game to make it fair. Like we said, lower the cost or improve the probability of winning. Okay, and we can play with those if you actually wanted to play with it. I did a little, and I figured out if you didn't change the probability of winning, like if it was still a 4 or a 6, you'd have to reduce the cost to about $8.33 to make the game fair. Okay, so you can play with either of those things. Okay, let's look at a few more examples. Okay, suppose it costs $2 to play a game where you roll a single 6-sided die. You get $10 if the die lands on a 6, and nothing if the die lands on any other number. Okay, so same idea. Let's figure out expected value, and we'll use the expected value to decide whether the game is fair. Okay, so let's ask the same question. What are the outcomes? What are the outcomes I have to worry about?
Either winning or losing.
Yeah, win or lose. Okay. And then you have to figure out what's the value of winning. Okay, so the value of a win. What do you think? Okay. It says right here, I get $10 if I win, but what did I have to pay to play the game?
You
$2.
pay 2, so it's $8.
Right, so the value of winning is $8. Okay, and what's the value of losing?
-2.
Negative $2. So there's my value. And the next thing I need is the probability of each. How do you win? You win if your die lands on a 6. So what's the probability of rolling a 6?
1 in 6.
1/6. Okay, that means the probability of rolling anything else is what?
5/6.
5/6. You're getting the hang of it. Here's your expected value calculation. Okay, why don't you take your calculators? Okay, if you don't have a calculator, you can use the Web 2.0 calculator. I have that up here. Oops, that's Desmos. Web 2.0 to type it in. So I have 1/6 times 8. Whoops, would help if I typed it in right. Okay, so that's the way you would type it in, and I'm checking up here. It looks like what I want. Okay, so I get negative 0.33333. Anybody else get that value?
Yeah.
Okay, so remember it's a money amount. Okay, so that means if you played this game enough times, on average, you'd lose 33 cents every time you play. Okay, so if I play it 100 times, I'd expect to lose on average 33 cents a play, so I'd be out 33 bucks. Okay, having played the game that much. Some of them would have been wins, some of them would have been losses, but it would average out to about that. Okay, so what do you think? Is the game fair or not?
No.
No, not fair. Not fair. Expected value is not fair. Okay, let's try this one. Okay, suppose it costs $3 to play a game where you roll a die. You get 20 bucks if it lands on a 6, 10 if it lands on a 1, and nothing if it lands on any other number. So this time, how many outcomes are there?
3.
3, yeah, okay. So let's put them this way. Win 20, win 10, whoops, and then lose. Okay, so those are my outcomes. But again, remember, I'm netting out the cost to play. So I don't actually win $20. It's 20 minus 3, right? Because it cost me $3 to play the game. Same thing with 10. I'm not actually winning 10. I'm winning 10 minus 3. And of course, if I lose, I don't win anything. I'm just out the $3. Okay, is everybody all right with the values of the outcomes? All right, next we have to think of the probability of each outcome. Okay, so probability of winning, netting out, and winning 17 bucks. Okay, well, I only win if I land on a 6. So there's 1/6 of a 1 out of 6 chance that happens. Okay, I net out a 7 bucks. If I land on a 1, well, there's only one way for that to happen out of 6. And what's the probability of losing then? Well, it's rolling anything but a 1 or a 6. So rolling a 2, a 3, a 4, or a 5, right? There's 4 ways to do that out of 6. Okay, everybody okay with the probabilities? Okay, I'm going to ask you compute the expected value. I want to make sure you can handle the fractions on your calculator. Okay, compute E of x. Okay. Anybody got a value for E of x? All right, anybody else getting the same value? Okay, a bunch of you are getting 2. Now that's a positive 2. Okay, so what do you think? Is it a fair game?
No.
No, it's not. Would you want to play this game?
Yeah, it's in my favor, but it's still not fair.
Right, it's not fair, but whoever set this game up didn't think through the finances. Okay, so whoever's running this game is going to lose money in the long run. Okay, so if this is a carnival game, you most definitely want to play it. Okay, because you have a good chance of making money on it. However, the person running the game, on average, will lose $2 for every person who plays it. Okay, why is that? Well, look at it. They're paying out too much money. Okay, so essentially, it's not a fair game. Okay, and especially to the one running the game. Okay, so you can see it can go either way. All right. Anybody questions so far? Are we good? Okay. Well, again, my objective is to just show you a bunch of different types of expected value questions so you get comfortable with the idea. Okay. And again, mainly most of the work of these questions is figuring out, basically what are the number of outcomes, what's the net value of each outcome, okay, and how much would you make or lose if you played the game enough. Okay, so here's a classic casino game, roulette, American roulette, and it has slots on the wheel. It's a wheel basically that the person running the game spins. You place your bets on where the little ball's going to wind up. Okay, so basically we've got slots numbered 1 through 36, and half of those slots are red and half of them are black. There are 2 slots numbered 0 and 00, which are green. If you bet 1 chip on a single number and the ball lands on that number, you get 35 chips plus the chip you played. Okay, so again, the idea is, say I play 7, okay, I bet a chip that I'm going to wind up in 7. If the actual ball winds up in the slot 7, I not only get my chip back, but I get 35 additional chips. Okay, everybody understand? And we're going to say the chips are worth $1. We want to know what are the expected winnings of a player who sits there at the wheel and keeps playing 17. Okay, for a long, long time. So first we have to figure out what are the outcomes. Okay, what are the outcomes of this game? The way the game is stated. Okay, I know some of you may actually be more familiar with it, but the way it's stated in the problem.
It's still only win or lose, right?
Yeah, it's win or lose. Okay, now, if you win, what's the value of winning? It costs you $1 to play, right? But you get that $1 back. Okay,
36.
so essentially what do you have here?
$36.
Well, it's essentially, if you think about it, it's 35, right? Because you played $1 and you get it back. Okay. All right. So you give the person running the game your chip. Okay. So it would be taking that away, and then he gives it back to you. Okay. So you make $35. Okay. How about if you lose? You're out the $1 chip, right? Okay, now there's 36 spots on the wheel. If you're playing 17, how many slots are labeled 17 out of the 36?
1.
Just 1. Okay, so 1 out of 36 is the probability of winning. And again, all of the other slots, 35 out of 36, are losing slots. Okay, You most often see an expected value look like this, where the very large probability is on losing, see? So let's try this. Use your calculator and tell me about the expected value of this.
What about the 0 and the double 0?
Okay, you can pick those as well, okay? Oh, I see what you're saying. You're saying those are two additional, I gotcha.
Yeah.
Okay. So we have 1 out of how many? Okay,
38.
38 slots. Gotcha. Okay, so we have 1 out of 38 because it could land in 0 or double 0, right? And then we have 37 out of 38 possible losing slots. Okay,
Well,
thanks.
that's even worse.
That's even worse. Okay, so figure it out. Okay, see what your expected value is. And again, just round to 2 decimal places. Oh, wait.
Yeah, it's only 5 cents.
Yeah, you're out 5 cents. And a lot of people say, well, you know, it's only 5 cents. Does everybody play just once? No. Okay. And again, the casino has to have an edge. Okay. That's why they're in business. All right. So essentially, on every spin of the wheel, the casino, and again, this is multiplied by everybody who's playing. So it's not just every spin, it's every spin times however many people have put money down. Okay. So if they've got, say, 20 people playing, okay, they make a buck every time that wheel turns. Okay. So again, not a fair game, but you'd expect that because casinos aren't in operation for their health, they're in operation as a business. Everybody all right with this? Okay. Yeah. All right. Let's look at a crowdfunding example. Super random, but my dad is a slot tech at casino. It's crazy listening to, oh my gosh, yes. Okay, there is something called a gambler's fallacy. Okay, whoever shared this, thank you. Okay, Lex, thank you. Basically, a lot of people feel that I'm going to play the slot machine all afternoon because it's guaranteed to hit at some point. Okay, that's called the gambler's fallacy. And basically, they're afraid that if they leave that machine and somebody else sits down, that person's going to hit. Okay, because the machine is due. Okay, that's not how random works. Okay, you can lose a lot of money thinking like that. Okay?
There's literally a machine that it's one of like the Buffalo water machines.
Uh-huh.
And he's kind of picked up on like one of the tells that you're gonna hit really big on it. And so pretty much like when all the buffaloes are like facing you, like when all their faces are facing forward towards you, that's when you're like, I think you're a couple hits away from actually winning the jackpot or winning like really big. So he's picked up on a couple things, but yeah,
Oh
it's
my gosh.
literally people there every single day just
Right. I'm sure your dad realizes too that there's this whole army of people upstairs watching the playing floor. Okay.
Yeah.
Not only watching for people cheating or doing, illicit stuff, but they're also collecting data. There's a lot of mathematics that goes into running a casino, both computerized mathematics and just, like you said, looking for tells and things like that. Again, it's big business. And believe me, whenever there's big business, probability and statistics comes into it. Because you want to minimize your risk. That's the whole point of probability. So you want to make sure you work these numbers out in advance. and that the house has an edge, even if it's only 5 cents. Okay. This will play out in volume. Okay. And like you said, you know, they'll be there all afternoon. So eventually the house wins. Yep. My great grandfather got banned for counting cards. Oh my gosh. Yeah, exactly. Again, thank you so much for sharing these stories because they make it so much more real. Again, all I can say is casinos, particularly today in the now that everything's computerized, all the machines are computerized, it's so much easier to collect data on this. Okay, and the casino really needs that information. As a matter of fact, I recently part of what I do is like look at job postings that might appeal to students who say graduate with a STEM degree or whatever. And I've noticed a lot of casinos are looking for data analysts. Okay, so that's a very mathy job. And if any of you are really interested in probability and stats, that might be a job in your future. Okay, lots of people use data analytics. Okay, marketing, medicine, just about everything. Okay, and you're kind of dipping your toe into it here. I know most of you will be taking GBS 221 next, which is a more fully developed stats class. But don't hesitate. I mean, data analytics has become a big thing, especially in the last 10 years. Okay, so again, thank you so much for sharing all of that. Let's take a look at this one, crowdfunding. You're considering, you're a high roller, right? You made a lot of money at the casino, so now you have $10,000 to invest in a tech startup through crowdfunding, an equity crowdfunding campaign. You've determined there's a 35% chance you will lose everything, a 30% chance you'll break even, and a 25% chance you can double your investment, and a 10% chance, wow, you'll triple your investment over the next 5 years. What's your expected value? Okay, so let's look at the outcomes. From looking at this, I can see here's one outcome is lose. Okay, here's another outcome, breaking even, which means I don't get anything. Okay, namely, I wind up with essentially getting nothing out of the investment. Okay, so basically zero, right? I put in 10,000 and basically got nothing back. I didn't lose it, okay, but I didn't earn anything either, okay? 25% chance means I get another 10 grand back, okay? All right, and then basically here, I wind up tripling my investment, okay? So my investment will triple, okay? So I have okay? So you have to think about what are the values of the outcomes, okay? So I'm going to ask you, I've got 4 outcomes. What are the values of the outcomes? What do you think? Okay. Well, let's put it here, lose. All right, and then a break even. Double your money. Triple your money. Okay? So basically, lose means I'm out 10 grand, right? Okay? Break even means I don't make any money, but I don't lose any money either. Okay, so if you think of it as I have to put in 10 grand to play. Okay, so here's where I lose it all. Here's where I put in 10 grand and I make 10 grand. So I net out, I get 0. All right, how about double the money?
10 grand.
Yeah, think of it like this. Double your money is 20 grand. but it costs you 10 grand to play. All right. So you made 10 grand. All right. And how about triple? Will that be 30 minus the 10 grand to play? Okay, everybody see the values of the outcomes? Okay, now let's put it together in an expected value statement with the probabilities. Okay, my probability of losing everything was 35%. Okay, my probability of breaking even was 30%. My probability of doubling my investment was 25%. And tripling my investment was 10%. Okay, everybody all right with that? Okay, see if you can evaluate the expected value. You evaluate it. I'll do the same thing. Okay, you can type in done when you're ready. Okay, what did you guys get for an expected value? Yeah, 1,000. Okay, so what do you think? Should you invest? Okay. Again, what you would want to consider is you made $1,000 on 10,000 over 5 years. Okay. Now, if you had made it in 1 year, that'd be like a 10% rate of return, which is pretty good. Okay. And over 5 years, that averages out to what, like 2% a year? Can you do better anywhere else? Is the question you'd want to answer. Okay. You didn't lose money. Okay. Lose money. But can you do better elsewhere? Now, in this particular market, okay, where rates are super low, okay, this might be the best deal you can find, okay? But in a more normal market with more normal rates on things, okay, maybe you can do better than this. Right? But everybody understand, again, the expected value. Okay, everybody okay with this? Anybody got questions? Questions? Okie doke. Oh, let's look at my favorite example of all, because this happens to me all the time. Okay. Your friend Bill has decided to purchase a new, well, 50 inches isn't so big anymore, but a 50-inch flat screen TV at Best Buy for $479.99. When checking out, the cashier asked Bill if he wants to purchase the Best Buy extended warranty for his new TV. Okay, this is like so real. All right, the manufacturer's warranty covers 1 year limited parts and labor. The cashier tells him he can purchase a 2-year extended warranty for $69.99, okay, or a 5-year extended warranty for $99.99 that will cover repair and replacement, okay, if the TV breaks within the purchase warranty period. So here's what you want to understand is the 2-year warranty costs $69.99, okay, but it covers the whole purchase price of the TV. Okay, same thing with $99.99, okay, that covers the whole purchase price of the TV, only it's basically for a longer period of time. Now, Bill knows from his research the average failure rate of the TVs like the one he's purchasing is 3%. Okay, what do you think? Should he purchase the warranty? Okay, so again, let's think of the outcomes. Okay, so outcomes. Okay, the outcomes are either the 2-year warranty, okay, we'll do 2 expected value calculations, okay, one for the 2-year warranty and one for the 5-year warranty. Okay, so what we want to figure out is what's the value to Bill, okay? Now, let's say Bill has a defective TV, okay? So he needs to make a claim on the warranty. And here's where he doesn't make a claim. Okay, so here he's got a perfectly good television, and here he's making a claim on the warranty. Okay, I think everybody can figure out the probability of not making a claim. Well, the failure rate on the TV he's buying is 3%, which means 97% are good on average. Okay, so there's a 97% chance that Bill will be out $69.99 for his trouble. Okay, so he doesn't make a claim, right? That means he purchased the warranty, okay, but he never used it. There's a 97% chance of that because 97% of the TVs are not going to fail. Okay, now let's look at the probability of him making a claim. Let's say he gets one of the 3% of lemons, TVs that are defective. Okay, they tell him they'll reimburse him for the cost of the TV, and the TV was how much? It was $479.99, but he had to buy the warranty for $69.99. Okay, how does that look? Does that look like a reasonable expected value calculation for the 2-year warranty? Okay, anybody have any comments or questions? How are we doing? Okay. Well, let's figure that out. Okay, I'll go over to the calculator and put in these numbers. Clear it. So there's a 3% chance that he'll actually make a claim. Okay, so the TV was $479.99 minus $69.99. Okay, so that's the term for making a claim. And then here's the term for not making a claim. 97% of the TVs are good, but that means he's out the $69.99. What do you think? Okay, so let me put this in the chat. The expected value of this warranty to bill is negative 55.59. Okay. Okay, so that's telling you, on average, Best Buy is making $55.59 on every one of these warranties it sells on this TV. Because the failure rate is too low. Okay, not that many people make claims. Okay, everybody see it? Let's try it with the 5-year warranty. Okay, so with the 5-year warranty, here's the make a claim. And here's the doesn't make a claim. All right, so again, 3% of the TVs are defective. It costs $479.99 to the company to replace it. And the 5-year warranty was even pricier. It was $99.99. Okay. And the probability he doesn't make a claim, that's 97%, in which case he's out almost $100 for the warranty. Okay. So let's figure out that expected value. It's very similar to what I've already gotten in the calculator. So let's go back to my Web 2.0 calc. Okay, I'm going to click on this to put it back in here. And I'm just going to go and edit and change the 6s to 9s in the price of the warranty. Okay, that's what I like about this calculator. This is very easy to make changes. Okay, for this one, my expected value is negative $85.59. Okay, everybody all right with that? Okay, so here, on average, okay, people who buy the warranty are out $85. Okay, so basically they'll make some claims, but what it tells you, you are just one consumer. If you don't make a claim, you're out $99. If you do make a claim, well, that's great. They replaced your TV minus the $99 you gave them for the warranty. But what it means is, from the point of view of Best Buy in this example, for every one of these warranties they sell, they make $85.59. Okay, which is why they try to upsell you at the last minute when you're walking out the door. That's just business, right? Okay, so in general, if you've got a 1 year's manufacturer's warranty, you're careful with your electronics and you buy stuff with a good performance rate. In other words, this failure rate isn't high. The warranty probably doesn't make sense. Okay. Anybody got questions on this one? Anybody questions? Okay. I'm going to come back to the meeting. All right. So if nobody has questions on the general way to compute absolute value, there are a few other types of examples that you might see in the homework. For example, setting a premium, right? If a certain type of policy has a certain payout rate, like they know, for example, maybe 2% of all drivers in this demographic make an auto claim, okay? And then they tell you what the value of all the auto policies are. You can figure out what their expected payout's going to be using the same type of calculation, okay?